Hello everyone. Today we're going to be taking a look at polynomial long division. Now this might be some review from trig. It might also be new to some of you, so just take a look at this the same way that we did our long division with numbers on our last video. Now it's going to be set up the same way. We've still got our dividend, we've still got our divisor, our quotient, and a remainder, and the mechanics are going to work exactly the same way. Another way you can look at this is breaking a problem down into the dividend, divisor, quotient, remainder. Just like our quotient remainder theorem, this is also in your packet. So let's walk through how we would do this. We're dividing 5x squared plus 3x minus 2 by x plus 1. We're going to start out the same way that we would in a long division problem with numbers. So we have our dividend underneath our division sign, our divisor outside, and then we start out by looking at this 5x squared and divide that by x. We're only looking at the first term of both the dividend and divisor. So 5x squared divided by x, so we end up with 5x as that piece of the quotient. So then what we do is take this 5x, this piece of the quotient, and multiply it by our entire divisor. So we'll do 5x times x, our product is 5x squared, 5x times 1, we get 5x. Then, just like we did in our other long division problems with just numbers, we're going to subtract this from the dividend. So 5x squared minus 5x squared is 0, which is what it should be. Then we have 3x minus 5x, so we will get a negative 2x. If you're having trouble with this step, just relate it back to the long division problems with numbers. It's the same mechanics, just with some variables involved. So then what we do is bring down this negative 2. So we have negative 2x minus 2. So what we do is take a look at this negative 2x, just the first term, again with this, and divide that by just the first term in our divisor. So negative 2x divided by x is going to be negative 2. So then we take that negative 2, multiply it by our entire divisor. So negative 2 times x, negative 2 times that 1. Then we subtract these. So just like with our long division problems with numbers, we'll subtract this and end up with a remainder of 0. So our quotient is the 5x minus 2, and our remainder is 0. Let's take a look at another one here. So we still have our divisor outside the division sign, but what we have to do inside here is add our spaces. So we need placeholders. So we start writing this out. We have 27x cubed. But then it's just plus 64. We need to have terms that decrease by 1 in degree. So 27x cubed plus 0x squared plus 0x, and then we have our plus 64. All right. It'll work the same way as our last one. So 27x cubed divided by 3x. Remember, just our first terms. So 27 divided by 3 is 9. X cubed divided by x is x squared. Then we take that 9x squared, multiply it by our entire divisor. So we end up with 27x cubed and plus 36x squared. Remember, we are subtracting this entire next row, so we will end up with a negative 36x squared. This is something that if you're not having success in finding the correct answers, or you end up with something in one of these problems that it feels like it's taking you off in a direction, go back, check for your signs. That is the most common mistake that's made with these. So then we bring down our 0x. So then we take our negative 36x squared, divide that by 3x. Again, just the first terms. So negative 36x squared divided by 3x will be negative 12x. So then we take that negative 12x, multiply it by our entire divisor. So we end up with negative 36x squared minus 48x. We subtract. So it will end up with a 0x minus a negative 48x. So we will end up with a positive 48x here, plus 64, because we've brought that down. We take the first term again, so 48x divided by 3x. So we end up with 16. So we take that 16, that piece of the quotient, multiply it by our entire divisor. And here we have another remainder of 0. So we're going to be practicing these more in class and looking at some additional ways to perform some of these long division problems. Thanks for watching.